What's up, math scholars? We're doing 3-6 direct variation. We actually only have 3-6 and 3-7 left. The chapter's over. So if you're wondering the schedule, we have a quiz coming Friday. And then we'll have a chapter test coming up next week on next Thursday. So a couple things coming up. Who's excited for 3-6?
Yeah, math scholars.
All right, we briefly talked about this a couple days ago, but I didn't have you write it down, so now I'm having you officially write it down. Parallel lines have equal slopes, and they never, ever, ever cross. You could extend these lines forever, and since their slopes are equal, they will never cross. All right, so we are going to look at these three lines. All eyes up here. All eyes up here. Hello. Okay. We are just going to count. We're not going to use the formula. We're just going to count rise over run to figure out the slopes of line A, line B, line C, and figure out if any of them are parallel. Does it look like any of them are parallel? Maybe B and C. Let's count the rise over run. So here's line C. Rise over run would be 1, 2, 3, 4, 5, 1. 5 over 1. So my slope is positive 5 over 1. It's going uphill. Let's try line B. Here I'm at. Rise 1, 2, 3, 4, 5, 1. 5 over 1. Good guess. So B and C are parallel. Let's try line A. Line A is right here. 1, 2, 3, 4, 1. 4 over 1. So close, but no cookie. B and C are parallel. So, okay, how we count slope? Rise over run. Okay?
Y1.
Okay, now they're giving us two formulas. We don't have to make a graph to figure out their parallel. We just have to find the slope. Now, are either of these already in slope-intercept form? Slope-intercept form is y equals mx plus b. Are any of them already solved for y? Which one? Point to it. Very good. So what is the slope of this line that you're all pointing to? So it's a 0.5 slope. So what we're going to do is solve this one for y, get y by itself, and see if it also has a 1/2 or a 0.5 for its slope. Normally you can solve for y in 2 steps. So what's step 1? Subtract what? Good job. Jose is a scholar today. So that gives me a negative 8y equals negative 4x plus 8. One last step, and we will be solved for y. Anthony?
Divide by negative.
Yeah, divide everybody by negative 8. Is it looking good or bad? Do you think our slope will be a 1/2? I think it will. A negative 4 divided by negative 8 is a positive 1/2. So we're good. Our intercepts are different. No, wait. Oh my gosh. Look at this. Our intercepts are the same and our slopes are the same. So wait a minute. Oh my gosh, this is crazy. If you have the same exact slope and the same exact intercept, it's the same exact line.
So they're not parallel.
So I would say not parallel. I didn't anticipate that coming. Not parallel. Same line. Hey, we just did this whole problem and I figured I wasn't on record, unfortunately, unless I paused it halfway. But what we did, they were asking to find a value of k, so that would make the lines parallel. We found the slope of line A to be 3. We set up the equation for the slope of line B, set it equal to 3. And you can kind of look at our work. All those double negatives turn into positives, and we finish it off with a proportion. Maybe pause the video and kind of study that work a little bit to figure out. We figured out if k was negative 23, line A and line B would have the same slope, and they'd be parallel. All right, this was actually the title of the lesson, if you remember the title page, direct variations. Let's learn what direct variation is. Somebody wake Nick up. Wake up, Nick. We're learning about direct variation now. Direct variation is a little bit unique. If you look closely at the equation, of direct variation, all eyes right here. If you look closely at the equation of direct variation, A is slope, but there's no y-intercept. So the y-intercept is 0. I kind of had that written right here. Slope is A, the y-intercept is 0. That's direct variation. So we'll be looking at equations, and you'll be telling me, yes, is it direct variation? Or no, is it not? And you're mainly checking to see if that y-intercept is 0. Okay, so we're going to look at all these different equations. We're going to try to get them into slope-intercept form, and we're going to say yes or no whether it's direct variation. So once it's in slope-intercept form, if it has a slope, but it has a y-intercept of 0, that would be direct variation. So what would I do to get this one into slope-intercept form? One step. Subtract what? Good. So if I subtract this 3x, I'd have y equals negative 3x minus 2. Is that going to be direct variation? Does that have a y-intercept of 0? Nope.
No.
That negative 2 ruins it.
Why you gotta ruin it?
What about the second column? If I have to solve for y, what would I do? Divide by what? Divide by the 1.3. Now I grabbed my calculator because that's going to be a weird decimal thing, and I'm actually going to turn the answer into a fraction. Remember the fraction button, math, enter, enter. 6.5 divided by 1.3. Oh, it ended up being 5. Well, that was easier than I thought. Does that look like it's direct variation? Does that have a y-intercept of 0? Yes. Now they said, if it does, name the constant of variation. The constant of variation is just the slope. So what's the slope? 5. Good job. The constant of variation is 5. And finally, that last one over there, we have to solve for y. I think you can do it in 2 steps. Someone mentioned the 2x. Is that Dylan? What are we going to do first, Dylan? Yeah, add the 2x just to get the x's living together on that right side. So we'll have 3y equals 8x. We have one more step and we'll be solved for y. Divide by 3. So it's 8/3 x. Is that going to be direct variation? Does it have that y-intercept of 0? Yes. What's the constant of variation? 8/3. Good job. All right. All right. I should have looked at. Oh yeah. Yeah. Okay. So we're going to do some graphing. I'm sorry I didn't pass out any graph paper. We're doing very minimal graphing. So you should be able to graph on your notebook paper today. Before we do any graphing on this one, let's get ourselves into slope-intercept form. So what would we do first? Yes, you have to solve for y. So you're going to divide by 4. And I would keep it 5/4x because that's your slope. The constant of variation is your slope. Now these are going to be a piece of cake to graph because where's that y-intercept? Yeah, so every single direct variation equation that we have to graph will start at 0. How easy is that? Let's make our starting point at 0, 0. Now, how are we going to do our slope of 5/4? Jose? Rise 5, so that's obviously up. But do we want to run 4 to the right or 4 to the left?
Right.
To the right, because it's a positive slope. 1, 2, 3, 4, 5. 1, 2, 3, 4. Puff, puff, positive. Now, what we can also do, and I highly encourage this, is we can drop down 5. 1, 2, 3, 4, 5. And we can go 4 into the left direction. 1, 2, 3, 4. It's also going to give you that puff, puff, positive slope. And your line will be straighter if you go both directions, up and left and down and right. Okay. This is a little different of a prompt. I know they're like dying to do board buddies, but this prompt's a little different. So let's kind of talk through it together. We got a graph. It's direct variation, I can tell, because it's running through 0, 0. So that's a quick visual check. We need to find the equation of the line. So any ideas how we can figure out the equation in slope-intercept form of this line? Solve for y? No. Solve for something though. Figure out the slope. Is that what you're gonna say? Right. Yeah, up and over. So let's count. All eyes right here. We're gonna count from here to here. Ready? 1, 2, 3. 1, 2, 3, 4, 5. So 3/5. Now, they actually have one more task for us. Let's read it. Then, find the value of y when x is 10. How would you do that? Yep.
Plus 10.
Actually, you would just plug the 10 in right here, so you multiply the 3/5 by the 10. Plug it in and calculate it. So 10 times 3 is 30, divided by 5, that'd be 6. So that just means that 10, 6 is a coordinate on the line, if you're graphing. That's what that means. Okay? No, I liked that problem. That was good. Okay, let's read this one. It's a little bit different. Yeah, they're all just a little different. Write a direct variation equation that relates x to y. All right. So I was thinking about this. This is basically their way of saying one coordinate on the line is 1326. What's another coordinate we know for sure will be on our line if it's direct variation? 0, 0. Very scholarly. If you said 0, 0, very scholarly. Let's figure out our slope and then we'll have our equation. So slope formula. Y minus y over x minus x. What would that end up equaling? Can you do that one in your head? Yeah? I think it'd just be 2. Isn't 26 divided by 13 2? Yeah, 2. So our equation is y equals 2x. Because again, our intercept is 0. They're always 0 in these direct variation functions.
Okay.
All right, we're going to do this problem as the can you graduate the lesson. So do this just like we did the previous and find the equation of the direct variation. The direct variation equation. Okay, this was our last one, so let's talk it out. I put the 45, negative 9 into coordinate. I also knew my line would be going through 0, 0, so I used those numbers to get my slope. Now this slope was a little harder than the last one. It ended up being a negative 9 over 45, and I reduced that fraction. You can divide the top number and the bottom number by 9, or the calculator can reduce the fraction for you. This was the graduation problem. So then you write the slope-intercept form with the negative 1/2 in for slope. The intercept was, of course, 0. Raise your hand if you graduated that one all by yourself. So there's your scholars today. Now the homework is a worksheet I'll be passing out to you if you're absent and watching the video at home that files on Polaris.